So we'll go through the entire process once again. It was interrupted in between. What we have? We have 1 0 0 0, that is 8, divided by 1 1, that is 3. So initially we have put all zeros in A, and the first number 8 or 100 has been put in resistor Q, and 0011 has been put in resistor M. Okay, so first step what we are doing, we are shifting left A and Q. So after shifting A and Q left, I'm getting 0 0 0 1 0 0 0. So you can see that this bit is empty, and this MSB has been shifted into A. Okay. Then what is the next step? A minus M. After getting A minus M, I am getting this result, and I am storing the result back in A. Therefore 1 1 1 1 0 is the result that I am getting. And Q is remaining as it is. Okay. Now again, what is the next step we do? We check what is the most significant bit. If it is 1, then you are doing A plus M, restoring A, that is the same, whatever is the upper, we are getting it the same result down over here. And we are putting 0 at the least significant bit, that is Q0. So this empty position will be filled up by 0. Okay, so this is a first iteration. How many times you have to repeat? You have to repeat this. You have to repeat this 4 times because we are having 4 bit. Now again, second step, second iteration. Okay, आता second iteration मध्ये काय करणार आपण, हे जो result आहे आपल्याला A आणि Q मधला, again we are shifting it. So shift it left by 1 position. This will become empty. Then do A minus M. So this is A, and M is 0 0 0 1 1. So after doing A minus M, I'm getting the result as 1 1 1 1 1. Keep Q0 as it. Keep the resistor Q as it is. Then check the most significant bit. It is 1. If it is 1, we are doing what? We are restoring A back. Restoring A by adding again M to it. So add A. So take 1 1 1 1 1 plus 0 0 0 1 1. So the answer I'm going to get is 0 0 0 1 0. And the second step you have to do is that this empty position you have to fill it with 0. Okay, so this is the second iteration completed. Now third iteration, again shift left. So after shifting this particular A and Q resistor left, I'm getting the answer as 0 0 1 0 0. Okay, and this bit is empty. Then do what? A minus M. Now after doing A minus M, I'm getting the result as, after doing A minus M, I'm getting the result as 0 0 0 0 1. Q will be as it is. Now what is the MSB? Now the most significant bit over here is 0. Remember, it is not 1, it is 0 now. Now if it is 0, then we are not restoring M, or we are not restoring A. That is, we are not adding A plus M. We are keeping A as it is. Okay, and what we are adding to Q0, last bit position, we are adding 1 to it. Okay, getting it the difference between the first and this process. So shift left, A minus M will remain common throughout. After doing A minus M, check MSB. If MSB is 1, then we have to restore A and add 0 to the Q resistor LSB. If the MSB is 0, then you have to keep A as it is. Don't add any M or anything to it. And you have to add 1 to the last bit. So this is the third iteration I'm getting. Now this is the last iteration because you have to repeat it 4 times. Okay, so again shift left. Now we have to again shift it left. After shifting left, I get this answer, 1 bit position. This is empty again. Now do A minus M because this is very common step. After doing A minus M, I'm getting the result as 1, 1, 1, 1, 1. Q, you have to keep it as it is. Okay, then check the MSB, it is 1. So if it is 1, then what you have to do? Restore A. That is add again M to A. Restoring A, you will get the same answer as it was in the previous step. And you put 0 over here. Is it clear? So now we have completed it 4 times. So stop. You are going to get the answer. So where will you get the answer? So in resistor A, we are going to get the quotient. So 0, 0, 0, 1, 0 is the quotient. And 0, 0, 1, 0, sorry, 0, 0, 0, 1, 0 is the remainder. And 0, 0, 1, 0 is the quotient. Okay, so in Q and A, you are getting the answer. In Q, you are getting the quotient, and in resistor A, you are getting the remainder. Is it clear? So this is called as a restoring division process. I will be sharing this PDF with you. It's my advice that you solve more and more examples, and it will become clear to you. Now, the second method that we are going to do is called as a non-restoring division. What you're doing in restoring division? In restoring division, you are restoring the A. That means you are adding A again and again to A minus M. Sorry, you are adding M. That is, you are restoring A again and again. So this is an unnecessary repetition of addition. So in order to avoid that, there is another method which is called as a non-restoring division. So what we do in non-restoring division? So this is a flow chart of non-restoring division. So if anyone is getting any difficulty, then you can go through the flow chart, but I won't explain the flow chart first. I will directly go to the process or procedure. Okay. And then we'll take one example and then we'll go back into the flow chart. The circuitry diagram is same as we have seen for the restoring division. There is no change in the circuitry diagram. Therefore, I'm not going to explain it again. Only the little change is the method. The procedure is going to change. So like restoring also, here also in the resistor M, we are going to store the divisor. In resistor Q, we are going to store the dividend. In resistor A, we are going to have all zeros. The output will be stored in resistor Q and resistor A. So quotient will be stored in Q and remainder will be stored in resistor A. So initial settings are also like the previous restoring division method. There is no change in that. Just the change is the procedure. Now see what we are doing over here. Now the entire process is divided into 2 parts. So this is step 1, which we are going to repeat n times. That means in the previous case, our dividend was 4-bit long. So we are going to repeat this process, only this process 4 times. Only step 1, remember that. Okay. So after this repetition, after you repeat the first step 4 times, then this has to be done only 1 time, last step. Step 2 is the last step. Okay, so here I have written over here, do n times. Step 1 is to be done n times. So what is to be done in step 1? First, you have to check what is the sign of A. What is the MSB, most significant bit of A? If it is 0, then we have to shift A and Q left 1-bit position. Then subtract A minus M and put the answer back in A. Okay. So in previous case, we used to do it by default. But now you have to check. You have to check what is the MSB, what is the most significant bit. If it is 0, then you shift A and Q and do A minus M. If it is 1, then do what? Shift A and Q left by 1-bit position and add A plus M. So if your MSB is 1, instead of subtracting as we did in the previous one, you have to add A plus M. Put the answer back in M. Next again what? Check again the sign bit of A. what it is. What is the MSB of A? If it is 0, then you have to set Q0 to 1. If it is 1, you have to set Q0 to 0. Reverse. जर MSB 0 असेल तर Q0 1 ला टाका. MSB 1 असेल तर Q0 you have to put it as 0. Okay. So what you have to do is that you have to repeat this process n times. So you have to repeat this 4 times for 4-bit dividend. And the last step is what? In the last step, if the sign of A is 1, then you have to add m plus A. If the sign of A is 0, I'll write it over here, else keep A as it is. Okay, that means if sign bit is 0, then don't do anything, keep it as it is. Is it clear what we have to do? So there is little change in that. Every time you have to see what is the most significant bit of A, and then you have to do A minus M or A plus 1, A plus M. Again, check what is the most significant bit of A. Then you have to put Q0 accordingly. So 2 times you have to check the MSB of A. Okay. And the first step is repeated 4 times, and the last step will be this, depending upon what is the sign bit of A. Now we'll take the example and we'll see how it is done. So again, we'll take the same previous example, 1 0 0 0 divided by 1 1. So what is there in register A? 0 0 0 0. What is there in register Q? 1 0 0 0. Okay. What is there in register M? 0 0 0 1 1 1. Same thing as we did in the previous one. Okay. Now what is the first thing over here? First thing is that you have to check what is the most significant bit of A. Initially, I will check what is the most significant bit of A. It is 0. So if the most significant bit of A is 0, what you have to do? First thing is that we have to shift left. So I am shifting A and Q left. So this A and Q, this is A and Q. I am shifting it left. After shifting it left, I get this answer. So 0 0 0 0 1 0 0 0. Okay, shift left. Then what you have to do now, this is 0. Okay, so the most significant bit we got it as 0. Therefore, you have to do A minus M. So here you can check. So what we are doing, first of all, we are checking the sign bit of A. If it is 0, we are shifting it, and if we are doing A minus M. If sign bit is 1, then we are doing A plus M. So now the sign bit is 0, therefore we have to do A minus M. Okay, so do what? A minus M. This is A 0 0 0 0 1 minus 0 0 0 1 1. So the answer I'm going to get is 1 1 1 1 0. Keep Q as it is. Clear? Next do what? Next now again check what is the sign bit of M. Getting it? We are checking it 2 times. We are checking the most significant bit 2 times. So if it is 0, we are doing A minus M, and if it is 1, then we are putting the value of Q0 accordingly. So if it is 1, we are putting the value of Q0 as 0. So I am putting it as 0. Is it clear? I repeat what we did. First of all, we had checked the most significant bit of A. It is 0. So if it is 0, we are shifting left and we are doing A minus 1, A minus M. Okay. Again, we are checking what is the MSB of A. It is 1. Then we are putting Q0 as 0. Clear? Now we have to repeat this 4 times because N is 4 over here. Now second step. Now again do what? Check the MSB of A. What it is? It is 1. Shift left. Okay, I have shifted it left. After shifting left, the MSB is 1. So what you have to do? You have to add A plus M now. It is not A minus M, it is A plus M. So what is A? A was 1 1 1 0 0. You add M to it, that is 0 0 0 1 1. The answer that we are getting is 1 1 1 1 1. Clear? Now then next do what? Again check the MSB. MSB is what? 1. If MSB is 1, then you have to put Q0 as 0. Is it clear? So we have completed second step. Now again third step. In again third step, now check the MSB. MSB is 1. So again we have to shift it left. So you have to shift it left back. So after shifting, I'm getting this answer. Okay, now again I have to check the MSB. So what is MSB? MSB is 1. If the MSB is 1, then you have to add A plus M. Okay, so if MSB is 1, add A plus M. So after adding A plus M, I'm getting 0, 0, 0, 0, 1. Then next, again check what is MSB? 0. If MSB is 0, this will become 1. I don't know how paint is activated over here. Please ignore whatever the signs are coming in between. Now finally the last cycle. In the last cycle again check the MSB. Whatever is the MSB, always you have to shift it. So shift it left 1 bit position. So now again check the MSB. It is 0. If the MSB is 0, you are doing A minus M. Do A minus M. Again check the MSB. It is 1. If it is 1, then Q0 is to be kept 0. So always you have to check the most significant bit. Remember that. Now this step I have repeated 4 times. Okay, next I have to go to step number 2. Stop after 4 cycle. So after 4 cycle, after the first step, you will get the quotient. Still, you are not getting the remainder, but you will get the quotient immediately after the first step only. So in the Q, I am getting the quotient 0, 0, 1, 0. For the remainder, I have to do the step 2. Now what is the step 2? What is the step 2? Step 2 is that you have to check what is the sign bit of A. If sign bit of A is 1, you have to add A plus M. So now check the sign bit of A. What is the bit? This is A, okay? Remember that this is A only. So the MSB is 1. जर तो 1 असेल, then you have to add A plus M. So therefore we are adding A plus M over here. So A was our 1, 1, 1, 1, and we are adding M 0, 0, 0, 1, 1. Is it clear? So, okay, so what was our A? 1, 1, 1, 1, and to that we are adding 0, 0, 0, 1, 1. And what answer you are going to get? You are going to get the answer as 0, 0, 0, 1, 0. So this is the remainder. Is it clear? So this is called as a non-restoring division. In the non-restoring division, we are having 2 steps. Step 1 will be repeated n times, and step 2 is the final step. Repeated, or it is done only 1 time to get the remainder. Again, जर हा sign bit 0 असता, okay, तर इथे काहीही करायचं नाहीये. Do nothing if the sign bit is 0. Okay, if this would have been 0, and you have to do nothing. You will directly get the answer over here. But now if it is 1 only, then you have to follow step 2. Okay, is it clear? Okay, so now this is your restoring and non-restoring division. So what I would suggest is that you try for this particular division using restoring and non-restoring method. Okay, so you have to try as an homework. You have to try, because almost we are going to end our what you can say, we are going to end our unit 3. Therefore